Hi, Hi, I'm making another video on section 6.3, the part 2 exercises. I just wanted to demonstrate how to solve number 15. So remember, this is one of those exercises where you're comparing two statements and doing a truth table for the two statements in order to discover what kind of relationship exists between the two statements. So you have to do a table for both statements, and ideally you want to place the truth tables next to each other. So here you can see that you have the two statements already written down next to each other. First thing in the order of business is to figure out how big your truth table will be. So remember, you need to count the types of letters. There's type Q with 3 tokens. There's type K with 2 tokens, and there's type F with 2 tokens. So you have 3 types. And so the formula, sorry. So the formula will be, you put down the number 3. I don't know why this is happening. And then you use that 3 as an exponent for 2. So you do 2 to the third. And the result of this is 8. So it's 2 times 2 times 2. So you know that you're going to have 8 rows to your truth table. You can number them here: 1, 2, 3, 4, 5, 6, 7, and 8. And then you have 8 rows, so you split the 8 for the first letter, and you do 4 T's and 4 F's for the Q. True, 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 and true, and then 4 F's. Remember the consistency, so you need to do the same under all Q's. So 4 T's and 4 F's. And again over here. You go back to the second letter, K, and you split the pattern that you used for the Q. So instead of 4 T's and 4 F's, you'll have groups of 2 and 2. So 2 T's and 2 F's, 2 T's and 2 F's. And you do the same for the other K. 2 and 2, and then again 2 and 2. And finally for the F, you're going to split the 2 and 2, and you'll have 1 and 1. So TF, 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 and again, and here again. This captures all the combinations, so you're ready to go with this. And remember, you always work from the inside out. So first you compute inside the parentheses, and then you move on to the main logical operators, those that are outside of the parentheses. So here on the left-hand side, you will start with K or F. You just worry about the contents of this parenthesis. You use the truth table for the wedge. So both true is true. Both, one true, one false is true. One false, one true is true. Both false is false. Both true is true. True again, and then both false, false. This is a little crammed, but you have to remember that you have to just look at this column. Now the central column, the one that is under the wedge. Now that column that is under the wedge is going to be reversed by the tilde that is up here or to the left, because this part of the formula says not K or F. So if K or F is true, for example, on the first line, not K or F will be false. So what you want to have under the tilde is a column that has the opposite truth values of the truth values that are under the wedge. So for example, the first three are T's, so you're going to have F's under the tilde. So this F reverses this T here. And again, this T here is reversed by this F. True becomes false again. False becomes true. True becomes false. True becomes false. True becomes false. And false becomes true. Okay, now everything you've done in the this area is going to be irrelevant because so I was saying everything you've done in the area under K or F is going to be irrelevant. What really counts is the truth value under Q and the truth value under the tilde here, because this is a conditional that says if Q, then not K or F. So you have to compare the values of Q and the values of not K or F, and those values are written under the tilde. So true and false for the conditional is false. True and false, false again. True and false, false. True and true, true. False and false, true. False and false, true. False and false, true. False and true, true. You're using the truth table for the conditional. So remember, conditional is only false when the antecedent is true and the consequent is false, as on the first three lines. Otherwise, it's true. So now we can go to the other side. This is a conjunction, so it's only going to be true when both components are true. So you can do this pretty quickly. It's true here and here, but here it's false, 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 and obviously down here, both false. It's going to be false. And again, you can do it quickly on this side, both true, true, false, true, false, 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 and false. Now, in order to compute what to put under the wedge, you need to look at what is under this dot and what is under this dot. This is a wedge, so as long as either side is true, the whole thing is going to be true. So true and true, true, true and false, still true, false and true, still true. False and false makes it false. Again, false and false makes it false. False and false, false again, false and false. Again, false, and here again, false. Okay, so you're finished with the truth table. So you still need to analyze the relationship between these two statements, and you'll be looking under the main connective or the main operator in the first. Sorry about that. You're looking here under the main operator in the first statement. So you look under the horseshoe, and here the main operator is the wedge. So you look under here. Okay. And it should be fairly quick because you can see that on the first three rows, on this side you have the F, on the other side you have the T. So that's true on the first row. On the second row they differ. On the third row they differ again. And then here there's a stretch of 5 T's on the left hand side and a stretch of 5 F's on the other side. So that means that on every single row, the truth value of the whole statement on this side and the truth value of the whole statement on the other side, they differ, they're opposite. So that means that they're contradictory. I hope this helps. Let me know if you have any questions. Thank you very much.